Hi, I used FashionMNIST dataset for this project. The reason of choosing this dataset is that I wanted to do image processing with the help of machine learning. And the second reason for choosing this dataset is that I wanted to cover up the bonus questions. So my dataset is more than 20,000, and also I ran the models in cloud. Let us begin with the objectives that I have for this project. The number one objective is that I wanted to do multi-class classification algorithm in the context of image processing, and also I did k-nearest neighbor analysis, convolution neural network, and random forest classifier. Not only that, I did principal component analysis and ran different algorithms on the reduced dataset. I also ran my models in GCP. Let us begin with exploring the dataset. My dataset has 60,000 into 785 for training and 10,000 into 785 for test. Here this line is for, I used this for cloud, and then I began with importing the necessary libraries, then loading the data set, and after that splitting the data into features and levels. This is part of cleaning the data. Fortunately, I have no null values. Then I went on exploring the unique labels that the data has, then generating 20 random samples, and after that I did PCA, which is for dimensionality reduction, mainly for capturing the 99% of the explained variance, that is reducing the number of components by 300. And after that I splitted the data into three parts: train, validation, and test. So here I would like to say that the train data is splitted into train and validation, and another I have is test data. So here I'm defining two functions. One is matrix generator that helped me, that this function is used for generating scores for different models, useful for comparison. Generate confusion matrix function helped me create confusion matrix for different models, also useful for comparison. I began by creating a baseline logistic regression model on non-PCA dataset. Here is the matrix for that. Then the confusion matrix for train, for test. And then I went on creating logistic regression with PCA data. Here is the matrix for that, then the confusion matrix, and for training, and this is for test. By using this function generate confusion matrix, which I defined earlier. Here I developed k-nearest neighbor classifier with the non-PCA dataset. So here I got the optimal number of neighbors is 7, and then I went on creating the matrix for this model, and then confusion matrix for the training, for test data. And when I did k nearest neighbor on the PCA, with the PCA data, the optimal number of neighbors is 5. Previously with the non-PCA data it was 7. And then I went on generating the matrix for that, for this is the confusion matrix for train for test. And then I went on developing convoluted neural networks. These are the layers that I have. And then I did hyperparameter tuning with grid search, mainly on the parameters epoch, learning rate, and batch size. And here is the best parameter that I have after hyperparameter tuning. Then I went on running the model. This is the matrix for that, and also the confusion matrix for train for test. And then I went on creating another model, developing another model, which is the random forest classifier with the non-PCA data set. I did hyperparameter tuning with the help of grid search on the parameters, estimators, and depth. And I went on, this is the matrix for that, and confusion matrix for train for test. Then I went on doing random forest classifier with PCA data, also hyperparameter tuning with the help of grid search. This is the best parameters that I have. And then I did, this is the matrix for that. Then I went on doing confusion matrix for training for test. And here what I did is I tested the generated models against the test data, which contains 10,000 into 785 that is the data that the test data that contains 10,000 images, 10,000 into 785 images. So after completing the project, the observations that I have here are the references, some references I have given. The k nearest neighbor, I referred to an article. I've given all the links to that. And the conclusions that I draw from this is that the k nearest neighbor analysis, it becomes slower as the data set size increases. Also, it becomes slower as the number of neighbors increases. Number two is CNN with 3 layers is the best performing of all the models for all metrics. Number three is hyperparameter tuning is though time consuming, but it also allowed much more flexibility to and much more space for model improvement. And it helped me get the best possible models for this particular data set. And models trained on the PCA data was also faster than the non-PCA data on the non-PCA counterpart, and at the cost of a very small loss. I was able to train all models in Google Cloud, but I was not able to do the hyperparameter tuning in Google Cloud because the Google Cloud does not allow the models to run for more than 2 hours, at least in my case in Google Colab. It is not allowing me to run the models. So these are the conclusions and findings that I have. Thank you.